Hello everyone, and welcome to my YouTube channel. So today I'm going to look at this question: analyze the frame shown below by moment distribution method and plot the bending moment diagram. Now the frame has two spans and 3 columns, sort of. It has a point load of 20 kilonewton for span BC and span CE. The height of the vertical members is 4 meters. The span BC is 4 meters and CE is also 4 meters. The moment of inertia of B is 3I, CD is 3I, and EF is 3I. So I'm assuming this is I, this is also I. So let's calculate solution. Excuse me. Solution. Now this frame is symmetrical. We are going to take advantage of symmetry. So since the frame is symmetrical, consider frame A, B, C. So we're only going to consider that small frame. So that is 4 meters, and this is 3I, of course, and then we are going to, this is 20 kilonewton. So this is A, B, and C. So we are only considering this part of the frame up to point C here. Okay, good. So let's start with the step number 1, and the step number 1 is calculate the fixed end moments or FEM. So for MA, it is 0 because there is no loading. Same case as that is MAB, and MBA is also 0 because there is no load. So MBC is this one. We have a point load. So again, I'm taking my sign conventions. Clockwise moments are positive and clockwise moments are negative. So let's give you negative 20 times 4 divided by 8, and that will give you negative 10 kilonewton meter. So for MCB, that will be positive 10 kilonewton meter. Are we together? So the next step now, we are going to calculate the stiffness factors. We are going to calculate the stiffness factors and the distribution factors. So step 2 is calculate the distribution factors. So we are going to prepare a table as shown. So you have the joint there, you have the member, you have small k there, you have summation of k, and of course k over summation of k, which is now the distribution factor. All right, so let's do this. So we only have one joint, that is joint B. So we have member BA and BC. Now, if the far end is fixed, we use 4EI over L. And in both cases, the far end is joint. If you look at this question, this one is fixed and this one is also fixed. Good. So you just, for BA, the stiffness factor is 3I and this one is I. So this one you'll have 3 times 4 over 4, which will get 3. And this one you'll get 4EI over L. Again, it is 4 times EI is just 1 divided by 4, which is you get 1. So summation here, so I factored out EI. I'm not considering EI because I know eventually it will factor out on itself. So let me just write 4. So now the distribution factor, it will be 3 over 4 and this one 1 over 4. So the distribution factors should always add up to 1. The distribution factors should always add up to 1. Now let's now do our final step, and that is moment distribution. Step number 3, that is moment distribution. Moment distribution. Now for this, we are going to prepare a table again. We're going to prepare a table. So you have DF, you have FEM there, then you have here, you have A, B, and C. So the distribution factor here is 0. Here there are 2 at this joint, so you have 3 over 4, 1 over 4, and here of course it is 0. So the fixed moment here is 0, this one is 0, this is negative 10, and this is of course 10. So let's carry out our first distribution. So the out of balance moment between 0 and negative 10 is negative 10. So the balancing moment will be positive 10. So if you balance, this will be 7.5, this will be 2.5. Then you do the carry over. So half of this comes to this side and half come to this side. So this will be 3.75 and this is 1.25. So there is nothing else to distribute. There is no unbalanced moment. So the final moment now, final moments will be, if you add this up, this will be 3.75, this will be 7.5, this will be negative 7.5, and this will be 11.25. So thank you for watching. Of course, don't forget to like this video, and of course share.